Hi, this is Joe from the Math Perimeter. In this video, we will evaluate the improper integrals. The integral from 0 to 1 of 1 over root x dx and the integral from -1 to 1 of 1 over x dx. We begin by evaluating the integral from 0 to 1 of 1 over root x dx. Rewriting as a limit gives the limit as a approaches 0 plus of the integral from a to 1 of 1 over root x dx, rewriting the root in terms of fractional exponents, we obtain the limit as a approaches 0 plus of the integral from a to 1 of 1 over x to the 1/2 dx. In terms of negative exponents, this is the limit as a approaches 0 plus of the integral from a to 1 of x to the -1/2 dx. Integrating gives the limit as a approaches 0 plus of 2x to the 1/2 from a to 1. Using the constant multiple rule gives 2 times the limit as a approaches 0 plus of x to the 1/2 from a to 1. In terms of roots, this is 2 times the limit as a approaches 0 plus of root x from a to 1. Applying the fundamental theorem of calculus, we get 2 times the limit as a approaches 0 plus of root 1 minus root a, taking the square root of the first term gives 2 times the limit as a approaches 0 plus of 1 minus root a. Applying the sum rule, we get 2 times the limit as a approaches 0 plus of 1 minus the limit as a approaches 0 plus of root a. Using limit properties, we obtain 2 times the limit as a approaches 0 plus of 1 minus the square root of the limit as a approaches 0 plus of a. Taking the limits, we obtain 2 times 1 minus root 0. Taking the square root gives 2 times 1 minus 0. Subtracting gives 2 times 1 Multiplying, we arrive at a final answer of 2. Next, we evaluate the integral from -1 to 1 of 1 over x dx. This is equivalent to the integral from -1 to 0 of 1 over x dx plus the integral from 0 to 1 of 1 over x dx. Rewriting the integrals in terms of limits, we arrive at the limit as a approaches 0 minus of the integral from -1 to a of 1 over x dx plus the limit as b approaches 0 plus of the integral from b to 1 of 1 over x dx. Now we compute each integral individually. First, we consider the limit as a approaches 0 minus of the integral from -1 to a of 1 over x dx. Integrating gives the limit as a approaches 0 minus of the natural log of the absolute value of x from -1 to a. Applying the fundamental theorem of calculus, we obtain the limit as a approaches 0 minus of ln absolute value of a minus ln absolute value of -1 as our function approaches 0 from the left. The first term grows large in the negative direction while the second term approaches a constant. Hence the limit is negative infinity, so we conclude that the limit as a approaches 0 minus of the integral from -1 to a of 1 over x dx diverges. Since one of the integrals diverges, our entire integral diverges. Hence, our final answer is the integral from -1 to 1 of 1 over x dx diverges. Thank you for watching. I hope you enjoyed the video. Please like and subscribe. Thank you. See you next time.